Hello, statistics students. This is Mr. Gazzato, and I wanted to review today's lesson on inverse norm command. So if you look at problem number 9, I wanted to explain how to do that for the people that needed to see the calculator commands again or just wanted a refresher. So in problem number 2, we would press inverse norm. And then for the area, we would press 0.77. The mean is 0, and the standard deviation is 1. And those with the calculator left, center, right, you would highlight the left. And to do that on your calculator, you would go second distribution. So second var, second distribution, you would press number 3. And let me do that again. So second vars, you would press number 3. And you would say area 0.77, 0, 1, and some calculators have left, center, right. You would want the left highlighted. And when you do that, you get 0.7388. So the answer to question number 9, it says 2 decimals. So I would round that to 0.74. The next problem that we did in class was a problem like number 12 here. For problem number 12, we would do inverse norm. The area is 0.65. The mean is 0. Standard deviation is 1. And for the left, center, right, we would highlight the right. People that do not have that calculator, you actually need to find this area in yellow. And since the area is 1 underneath the curve, the yellow area is 1 minus 0.65, which is 0.35. So people without the left, center, right feature, you would use your calculator, second distribution, inverse norm. Your area would be 0.35, and then you would move down to paste. And when you do that, you get negative 0.39. The next problem that we wanted to talk about in class using inverse norm was problem number 15 here. For people with the left, center, right calculator, we would do inverse norm. The area would be 0.4. The mean is 0. Standard deviation is 1. And left, center, right calculators, you would highlight center. For people without the left, center, right feature, you would want to split this in half. So half of 0.4 is 0.2, and the other half is 0.2. Half of the curve is 50%. So people without the left, center, right, you have to do 2 problems. So you would do inverse norm. Your area would be 0.5 plus 0.2. Mean is 0. Standard deviation is 1. And then you would paste and get an answer. You have to do a second problem, inverse norm. Your area would be 0.5 minus 0.2. Mean is 0. Standard deviation is 1. So on the calculator, inverse norm, 0.5 plus 0.2. And when you go down to paste, so this positive z-score is 0.5244. And then you redo that for the negative value, inverse norm, and I'm going to say 0.5 minus 0.2. go down to paste. And you actually don't need to do the negative. One, because of symmetry. So once you get one answer, you probably will realize they are symmetric. People with the left, center, right, you get the answer right away. Then we move towards the application. So I'm going to review this question here that's in the homework. So the shaded area equals 70%. What is the z-score for the 70th percentile? So we would do inverse norm. The area is 0.7. We could say the mean is 0, standard deviation of 1. And for the left, center, right people, we would highlight left. So on the calculator, second distribution, inverse norm, 0.7. And when you go down to paste, you get 0.5244. So the z-score for the 70th percentile is 0.5244, rounded to 2 decimals, 0.52. Here we got the 95th percentile. So we're going to repeat that. Second distribution, inverse norm, but here we want 0.95 for the area. Moving down to paste. So 1.644. So the 95th percentile z-score is 1.64. The next problem says the 80th percentile. So for the 80th percentile, we'll repeat that. Second distribution, inverse norm, and we're going to change this to 0.8. For people with the left, center, right, you still have left highlighted. So 0.84. Here, for this problem, it says the shaded area represents the 99th percentile. And then I've added something here. An exam score is normally distributed with a mean of 76 points and standard deviation of 6. Find the exam score for the 99th percentile. Again, we're going to have left highlighted on the calculator. So I'm going to go second distribution and press inverse norm again. I want the 95th percentile, 99th percentile, so 0.99. You're told that the mean was 76 and the standard deviation was 6. So for the mean, we're going to type in 76, and for the standard deviation, we're going to type in 6. This is going to do the same type of calculation, but instead of giving you the z-score, it's going to give you the score on the actual test. So I need to press that again. I typed it in the wrong spot. So moving down to paste. So the score is 89.96. And I'm not sure how many decimals I need here. So 89.96. I'll just go 2 decimals, 89.96. In the next problem, we want the 95th percentile. For this particular problem, if you read the paragraph, the mean is 61 pounds and the standard deviation is 2 pounds. So when I use my calculator, I want the 95th percentile. So I'm going to go second distribution, inverse norm, and we want the 95th percentile, so 0.95. The mean was 61, and the standard deviation was 2. We're going to move down to paste. So the score is 64.29. Or sorry, the number of pounds is 64.29. In this third problem, we want the 80th percentile. The bag of Skittles is normally distributed with a mean of 185 and standard deviation of 4 pieces. So we're going to repeat that. Second distribution, inverse norm, we wanted the 80th percentile. The mean was 185 and standard deviation was 4. I'm going to type those two values into my calculator. And I'm going to go down to paste. So 188 pieces of candy is the 88th percentile. I hope this short little video helps you understand the inverse norm feature.